Welcome back. We're going to keep doing some of these problems here. We did number 1 and 2. Let's look at number 3. We want to integrate the square root of x dx. Well, welcome to my world of language, math language. So I wrote it down, the integral of x, square root of x dx. Now, what can we integrate? We can integrate a constant, a power of x, e to the x, and 1 over x. Just 4 things. That's it. And this is going to be, it's certainly not e to the x or 1 over x, but we can write it as a power. So we had to do this when we differentiated as well. We had to rewrite that as what? X to the 1/2 power. And notice I haven't integrated. This is just a total rewrite so that you have a power. And you can use the power rule, what sometimes is called the power rule over here. The power rule, which says I add 1 and divide by it. Now, 1/2 is not as easy to add 1 to as if it were a whole number, so I'm going to show you. And the integral and that dx go away as soon as you do a rule, and I'm adding 1 to it and dividing by that same power. Now you just got to go what 1/2 plus 1 is. Some of you may have to use a calculator, but I did this before I started, so I know it's 3/2 over 3/2, so I wrote x to the 3/2 over 3/2 plus c, and don't forget that plus c. And now, if you divide by 3/2, it's the same as multiplying by 2/3, so I wouldn't leave that down there. Just flip it up here, and there is your antiderivative, or integral. Of what? We're talking about this, x to the 1/2. So the antiderivative, or the integral, is 2/3 x to the 3/2 plus c. And you can always check by taking the derivative of this. So if I were to take the derivative of that, let's see, it would be 2/3 times, and then you bring the 3/2, x to the 3/2 minus 1, and then the derivative of the constant is 0. Sometimes it's more complicated to do this, but I'm just kind of showing you that 2/3 and 3/2 give you that. X to the 3/2 minus 1 is x to the 1/2, which again is that square root of x that we were finding the antiderivative of. We started with the square root of x, and we did our power rule and got the antiderivative. So I could take the derivative of that, and I get that square root of x back. Number 4. So we won't do that all the time, but you can always check if you have time. The integral of 5 over x dx. Now constants can be moved outside of integrals, so I'm going to show you that. Maybe. Here's what I'm doing. I wrote 5 over x dx is the integral. This is just a rewrite. You get 5x to the negative 1 power. Now I have a power here. However, it's a negative 1 power. If you have a negative 1 power, we're dealing with the ln of absolute value of x plus c. So what I do, now this 5 can just be written as 5 times, and then integrating x to the negative 1 becomes ln absolute value of x plus c. And that is number 4. Let's take a look at number 5. We're on a roll. So 5 is the integral of e to the x plus x squared plus 5. Now we write it down. So if I'm integrating e to the x plus x squared plus 5, well, the integral of e to the x, it's over here, is itself plus c. So I'm going to integrate e to the x, and I'm going to integrate x squared and use the power rule, which says I'm just going to add 1 to it and divide by it. And then I've got a constant. And a constant, the integral of a constant, is just kx. And then we'll put plus c at the end. So here we go. The integral of e to the x. And notice, as soon as you integrate, this integral and the dx go away. So I've got e to the x plus x to the 3rd over 3 plus 5x plus c. And that's simplified. There's nothing else to do here. Done. Number 6. Let's have something more challenging. That looks more challenging. The integral of 2 over x plus 3 over x squared dx. Let's take a look at that. So I wrote this down. Now we need to rewrite this. Nobody likes denominators, so we're going to rewrite it, take things up out of the denominators, and So think about your algebra skills. This is going to be 2x to the negative 1 when you put it up in the numerator, and 3x to the negative 2. You had to do that when you differentiated as well. But now the rule is we're going to take the integral of x to the negative 1 when x is to the negative 1. That's the ln absolute value of x. And this one, we're going to use the power rule. So this one you end up with ln, and this one is power rule. So watch this. I get 2 absolute value of x. So that's all of the 2 is just that constant on the outside. So that just comes along. And that x to the negative 1 gives us ln absolute value of x. Plus now the 3, again, is just a constant. We'll put him there and multiply by. And power rule. I'm going to add 1 to that and to that. And then put a plus c at the end. We're going to simplify that. So our 2 ln absolute value of x is lovely. We don't have to do anything to that. 3, now I'm going to add that. Negative 2 plus 1, negative 1 over negative 2 plus negative 1. And then these two can be combined to give us 2 ln absolute value of x minus 3x to the negative 1 plus c. And if you wanted to, you could even write that as 1 over x, but that's fine. As long as you have each term simplified, that is okay with me. All right, I'll come back for the rest.